In this class, now I would like to discuss with you nth root of unity and its properties. Nth root of unity, which is nothing but 1. In the first step, I would like to write this 1 as 1 plus 0 into I, where I is symbol of iota, you know. Now express this 1 plus 0 I complex number into the polar form. You know how to convert this Cartesian form of complex number into the polar form. R of cos theta plus I sin theta, where R is the magnitude or modulus of this complex number. So here magnitude is 1. Now what is the principal amplitude or principal argument of this complex number? 0, because here 1 comma 0, that point is lying on positive portion of x-axis, hence whose argument will be 0 degrees. So here write cos 0 degrees plus I sin 0 degrees. So this is the polar form or mod amplitude form of this given unity. So for this, what is there? Nth root. Now apply nth root on both sides so that you will get nth root of 1 can be written as, so here cos 0 degrees plus I sin 0 degrees whole power 1 by n. Now this can be written as, so cis of 0 degrees whole power 1 by n. So this is principal solution. You know, in the principal solution, this argument should be between minus pi to pi. So now with the help of this, I would like to write general solution of this. You know, general solution. For that we need to add 2k pi. So write the general solution of this nth root of unity. What do we get here? Cis of 2k pi plus 0 degrees. So whole power 1 by n. So here no confusion at all. In one rotation, so this is called principal solution. If you want more solutions, you need to add standard form of complete angle. You know, generally we write standard form of complete angle like this, 2n pi. If we complete one rotation, we put n equal to 1. If we write n equal to 2, we get 2 rotations like that. But we may get confusion between this n and this n. So that here I am using the letter k. 2k pi is the standard form of complete angle that should be added to this principal solution. Now hereafter apply the De Moivre theorem for this. If you apply the De Moivre theorem for this, so we get cis of 2k pi by n. You know, where k takes the values from 0, 1, 2 and so on till n minus 1. Okay students, now if we write k equal to 0 here, we get one solution. If we write k equal to 1 here, we get one more solution. Like that you have to substitute this k value from 0 to n minus 1 so that we will get n roots for this nth root of unity. Okay students, see, I hope you have understood till here. See, observe this. This can be also written as cis of 2 pi by n whole power k. Can I write like this? Yes, with the help of De Moivre theorem. Just I bring this k to index place. Now this can be transformed into this form. So what you have got inside? Cos pi by n plus, cos 2 pi by n. Cos 2 pi by n plus I sin 2 pi by n whole power k. Whole power k you have got. Now whichever we have got inside of this bracket, so that should be taken as omega. So here cos of 2 pi by n plus I sin 2 pi by n. This is omega. If you consider this one as omega, then it will become omega power k. This will be transformed into omega power k, where k runs from 0, 1, 2 and so on till n minus 1. If I write k0 here, omega power 0 which becomes 1. If I write k equal to 1 here, it will become omega power 1. If I write k equal to 2, it will become omega square and so on, omega power n minus 1. Okay students? So this 1 no, omega, omega square and so on, omega power n minus 1 are called roots of this nth root of unity. What are these? Roots of nth root of unity. What is omega here? Cos 2 pi by n plus I sin 2 pi by n. If I give n equal to 3, so in place of n you have to write 3. If I give n equal to 4, in place of n you have to write 4. And then you have to simplify. Okay students, I hope you have understood what are this 1 omega, omega square and so on, omega power n minus 1, roots of nth root of unity. Okay, next now I am going to add all of them. Okay, see, till here I think you have got it. Next now I am going to add all these roots. Yes, if I add, what I will get? 1 plus omega square plus omega cube and so on, omega power n minus 1. Add them. On adding this, what you people are going to get? Which are forming a geometric progression. Am I right? The terms of this series are there in geometric progression here. Term 2 by term 1 omega, term 3 by term 2 omega and so on. Hence, apply the sum of n terms of GP. As you know, Sn is equal to A into 1 minus R power n by 1 minus R. So here, first term is how much? 1. So, minus R, term 2 by term 1, omega power n by 1 minus omega. So, you know, nth root of 1, let it be x. Now, x equal to 1 power 1 by n you can write. Take power n on both sides. X power n is equal to 1. You know students, omega, just now we have written the roots of the 10th root of unity. 1 omega square and so on you got na? Omega is one of the root of this equation. Hence in place of x you can write omega. Omega power n is equal to 1 you are getting. Why I have written this omega here? I think you came to know. Omega is one of the root of this nth root of unity, no? Hence I replaced x by omega so that I got omega power n equal to 1. Now write omega power n as 1. If I write 1 here, 1 minus 1 by 1 minus omega. 1 minus 1, 0. 0 by something, 0. So on simplifying this sum, how much you are getting students? 0. So sum of all the roots of that cube nth root of unity is equal to 0. Remember this point. Okay students. Otherwise from this equation also you can say, okay, here x power n is equal to 1. So here if you bring this 1 to the left side, you get x power n. So minus 1 equal to 0. You know, sum of all the roots is equal to minus coefficient of x power n minus 1 by coefficient of x power 1, which is equal to 0 you will get. This concept you learnt in the theory of equations. This is nth degree polynomial equation. Sum of all the roots will be minus b by a. Na? B is nothing but coefficient of second term in the standard form. So here that is not there. Hence I kept to 0 by x power n coefficient 1, 0. Like that also you can say. But remember this procedure. Okay. I hope you have understood this. Sum of all the roots of this nth root of unity is how much? 0. Right. Now let us find product of all the roots of this nth root of unity. See here. 1 into omega square and so on, omega power n minus 1. Now if you take this product, you will get like this: omega power 1 plus 2 plus 3 and so on n minus 1. So here omega power, what you people have got here? Sum of first n minus 1 natural numbers. Am I right, students? Here observe the power of this omega. You have got natural numbers. How many? N minus 1. Hence whose sum will be n into n plus 1 by 2. But in the place of n you would have to write n minus 1. N minus 1. N into n plus 1 by 2. Okay. So both of them cancelled. What is left? Omega power n into n minus 1 by 2. Sum of first n natural numbers n into n plus 1 by 2. But here we have n minus 1 natural numbers. Hence in the place of n I wrote n minus 1. N minus 1 plus 1 by 2. So you got this. But as you know, omega value, how much have we got? Cos of 2 pi by n plus I sin 2 pi by n whole power n into n minus 1 by 2. So in the next step, apply the De Moivre theorem for this. So that what do you get? What do you get? Dump this one to here. So that you will get cos of n into n minus 1 by 2 into 2 pi by n plus I sin n into n minus 1 by 2 into 2 pi by n. See, these two cancel, n cancel. See, cancel these two. So what is left? Cos of n minus 1 into pi radians plus I sin n minus 1 into pi radians. Okay, students. Right? See, from there onwards, how do you simplify that? Students, here, n is any natural number. Okay? So, on simplifying this, you will get like this, sin n pi. As you learned, sin n pi as 0. In the trigonometric equations chapter, there you learned general solutions of sin x equal to 0, x equal to n pi you have written. So, here, replace that x by n pi, sin n pi, which becomes 0, where n belongs to any integer, either it may be positive or negative or 0. Okay, students? See, n minus 1 is an integer multiplying with pi radians, then result would be 0. Okay? Keep this result as 0. Then what about this? As you learnt, cos n pi radians equal to minus 1 whole power n. Cos n pi radians is equal to how much? Minus 1 whole power n. If n is odd, you will get minus 1. If n is even, this result would be 1. You know that. If you write n equal to 1, cos 180 degrees, you say it as minus 1, So if n is even, cos 360 degrees, if you put n equal to 2 here, which becomes 1. Okay, right. Now by that, this is going to be 0 and this is going to be by that minus 1 whole power n minus 1. Okay students, what is the product of all the roots of nth root of unity? Minus 1 whole power n minus 1. Okay, remember this. Right. Suppose in the cube root of unity, nth root of unity, if you write n equal to 3, we people are discussing nth root of unity. In place of n, if we take n equal to 3, what do you get, students? Cube root of 1, na? Cube root of 1. So this cube root of 1 you can write as 1 power 1 by 3. So it can be written x. So in the two ways you can answer to this question. What I am trying to find? Roots of this equation. Okay, cube root of unity. Cube roots of unity. Okay, so one you can find by solving this, otherwise by the complex numbers concept also you can answer. Okay, so in the complex numbers, what do you do? Same like previous one. Okay, just okay, what you have to write? This one as Cartesian form, like 1 plus 0i. Now transform this one into the polar form. What do you get? Like same like previous one. Cos 0 degrees plus I sin 0 degrees. Okay, now take whole power 1 by 3 and write in general amplitude form. So what do you get, Amma? Cis of 2k pi plus 0 by 3 you will get. Where k runs from, as I said to you, 0, 1, 2. 0, 1, 2. So that on writing k equal to 0, here what you people are going to get? K 0. So cos 0 plus I sin 0. Cos 0 is 1, sin 0, 0. Hence first root will be 1. If you put k equal to 1 here, 2 pi by 3. 2 pi by 3 means 120 degree. Cos 120 minus 1 by 2. Sin 120 root 3 by 2. So that you will get second root minus 1 plus root 3 I by 2. If you write k equal to 2 here, 2 to the 4. 4 pi by 3. So 240. Cos 240 minus 1 by 2. Sin 240 minus root 3 by 2. Minus 1 minus root 3 by 2. So in the previous one, so we got with this step omega power k. There inside of omega, what I have written? Cos 2 pi by n plus I sin 2 pi by n whole power k. Now there also you can write k012. By writing k012, in that also you will get these three. Okay, if you write k equal to 0, omega power 0 which becomes 1. If you write k equal to 1 here, you will get omega. If you write k equal to 2 here, you will get omega square. So here 1, the second one you can take as omega, third one you can take as omega square. Okay students, so here also if you add these three, 1 plus omega square, your result would be 0. Okay, add these three. So your result would be 0. If you take the product of these three, you will get omega cube, which becomes 1. So take the product of these three. Observe these two. This is the conjugate of this. This will be the conjugate of this. Vice versa. So one is real root and the remaining two are complex roots which are conjugate to each other. Okay students. On taking the product of these three, your result would be 1. Okay. Even that omega cube you can write as omega into omega square, which is equal to 1. So omega is equal to 1 by omega square you can write. So omega square is equal to 1 by omega you can write. Okay, so this omega, conjugate of omega is omega square, and conjugate of omega square is omega. So all this will help you while doing the applications. Okay students, many applications are there based on this cube roots of unity. Okay students, how we people have got this? By writing n equal to 3 here. Okay, otherwise you can solve this by this method also. See here, how do you do? Just to take a cube on both sides, so that here you will get x cube equal to 1. Now when you bring this 1 to the left side, you can write as x cube minus 1 cube equal to 0. Now solve it. X minus 1 into x square plus x plus 1 equal to 0. On equating this one equal to 0, you will get 1. On equating this one equal to 0, x square plus x plus 1 equal to 0. Now solve this. If you solve it, you will get like minus 1 plus or minus root of b square minus 4ac by 2a. So what do you get, Amma? Minus 1 plus or minus root 3I by 2. So if you take plus, you will get 1 root. So that is omega. Minus 1 plus root 3I by 2. If you take minus, you will get one more root. Omega square. Minus 1 minus root 3I by 2. Okay students? Right. So I am asking you to plot these three roots on a unit circle. Okay, if you plot the cube roots of unity on the unit circle, okay, you get one equilateral triangle. See, observe this. This is real axis and this is imaginary axis, complex plane, or you can call it as organd plane. So this is a unit circle having center 0, 0, radius 1 unit. So hence whose equation will be x square plus y square is equal to 1. You have got 3 roots. Am I right students? What is first one? 1. There is no imaginary part. Hence where do you get that? Here you will get 1, 0. And what about second one? Here you will get, because in the second one real part is negative, imaginary part is positive, means which belongs to the quadrant 2. Here you will get minus 1 by 2 comma root 3 by 2. Okay. So third one, here you will get, because both of them negative, real part and imaginary part. Okay students, see, if you connect them, you will get a triangle that is called an equilateral triangle. If you want, you can verify the lengths, measure the distance between from here to here, here to here, here to here, you will get same length. Okay, let us name these points as A, B, C. You got an equilateral triangle ABC. If you want to measure the length, you know how to find the length of this. So shall I find? AB is equal to how much? So here 1 minus of minus plus 3 by 2. So 9 by 4. This is, okay, 3 by 4 you will get. So you will get root 3 as this length. Even this length also root 3. This length also root 3. If you want, you can verify that length. After getting the side length, sometimes they may ask you whose area. You can able to find. Area of an equilateral triangle, you know. Delta equal to root 3 by 4 A square. A you got root 3, substitute here and go for simplification. Okay students? Right. So here you have got an equilateral triangle, a regular polygon. See, now again go back to the 10th root of unity. There you got n roots na. So if we plot those n roots on the unit circle, even which are also concyclic, which will be lying on same that unit circle only. See, x, x dash, y, y dash. This is real axis, this is imaginary axis. Okay, complex plane. So take a unit circle whose name is x square plus y square equal to 1. So you have got one real, remaining all are complex. So you got the root like this: 1 omega, omega square, omega cube, and so on. Omega power n minus 1 roots you have got. What is omega? You are well known. So cos 2 pi by n plus I sin 2 pi by n. Okay, students, right? See, now plot this roots on this unit circle. So real part here you will get 1 comma 0. Next omega you may get somewhere, second point, and third point you may get in other place, like that. Okay, students, rough diagram, not exact diagram, rough diagram. Okay, students, see, now if you connect all these points, let us say this point as like P1, P2, P3, P4, P5, P6, P7, and so on. Plot all those roots around the circle which are all concyclic. You know, all will be lying on this circumference of this unit circle. So if you connect them, if you connect these points, you will get a regular polygon. What kind of polygon do you get? A regular polygon you will get inside. Okay, students. So if you connect this center to these points, you will get n congruent triangles inside. How many triangles do you get inside? N congruent triangles means whose size and shape, means whose areas are equal. Okay. Now my question is, find the area of this regular n-gon, which is formed by connecting these points around the circle. How do we find? See, this length will be 1 because this is unit circle, this is unit circle. If you complete one rotation, then we rotate 2 pi angle here. If we complete one rotation, then how much angle rotated by us? 2 pi radius, you know that. So, as I said to you, all these triangles will be congruent. Okay, students. So, then each interior angle over here, 2 pi by n you will get. This 2 pi by n is the like phase difference. In the physics you call it as phase difference. If you take any two successive roots among this n, then whose argument difference will be 2 pi by n. Difference between the successive roots argument difference is how much? 2 pi by n. Suppose if you take omega, cos 2 pi by n plus I sin 2 pi by n na omega square. Omega square means for this you have to apply De Moivre theorem. So that here you will get cos 4 pi by n plus I sin 4 pi by n. Now observe the argument difference. These two are successive roots. Then whose arguments difference will be how much? 4 pi by n minus 2 pi by n. 2 pi by n you will get. So here also this angle will be 2 pi by n. How much amma? 2 pi by n. Now I am trying to find this triangle area. How I can find? Because you learned one formula in the properties of triangles. Solution to a triangle in the trigonometry. 1 by 2 AB sin C. You read this formula na? Apply that formula. 1 by 2. This is 1 unit, this is 1 unit. So, product of adjacent sides and sine of included angle. Here included angle is 2 pi by n na? Yes. You got one triangle area. But such kind of triangles, how many are there inside of that regular n-gon? There are n such triangles. Hence, to get area of this regular n-gon, you would have to multiply this result with n. Yes, multiply it. So, area of regular n-gon. Area of regular n-gon is equal to n into this. So, n by 2 into sine 2 pi by n. In some textbooks, they will write sine 2 pi by n as sine 2 theta, like 2 sine theta cos theta. Like that they will write. If you write, then your area will become like this. N by 2 into sine 2 pi by n. 2 sine pi by n cos pi by n you will get. So both of them cancel. Now n into sine pi by n into cos pi by n. So this square units. This is the area of that regular n-gon, which is formed by that roots of nth root of unity. Sometimes they will ask you this side length also. What do they ask you? This side length. How can you find that side length? So for that you do one thing. So just drop the perpendicular from the center to this side. Okay, na students. This total angle is 2 pi by n, and this altitude, this is called altitude. This altitude will divide this angle into two equal halves. Okay, then each one is pi by n, pi by n. So now here let us take this length is x and this length also will be x because this is midpoint. Now take this triangle and define sine pi by n. Sine pi by n, opposite by hypotenuse. So you will get x by 1. Now your x will be sine of pi by n. So if it is x and this length will be also x, then what is the side length of that regular n-gon? Distance from P1 to P2. So you have to double it. 2 sine pi by n units. So this is the length of that regular n-gon. So these two, okay, points are important from the diagram. Yes, next, students, here you would have to remember one more point. See, this result, 1 plus omega into 1 plus omega square into 1 plus omega cube and so on, 1 plus omega power n minus 1 is equal to 0 if n is even. This is going to be 1 if n is odd. Remember this point. Where w, this omega, omega square, omega cube and so on, omega power n minus 1 are complex roots of nth root of unity. Okay. So if you simplify this result, you will get 0 when n is even. Okay. If n is odd, you will get 1. If you want, I can give you n value is 4. If I give n value is 4, then whose roots will be 1 no omega, omega square, omega cube na n, fourth root of unity. So these will be the roots for a fourth root of unity. Fourth root of unity. So what is omega? You know, 1 no cos of 2 pi by n plus I sin 2 pi by n. N we are giving 4. 4 if you write here, cos 2 pi by 4. Cos 90 na? Yes, cos 90 which becomes 0. Okay, what about this? Sin 91. I you are getting. Omega, how much are you getting? I. Okay, so first one is 1, second one is I, and third one I square minus 1. Omega cube is I cube. I cube is equal to minus I. So these are the roots of cube root of, this fourth root of unity. 1 no I minus 1. 1 no is a real root. Keep it aside. But omega value how much? I. Omega square on simplifying minus 1. And what about this? I. Now substitute these three values over here. Here, how much do you get? Here 1 plus I, here minus 1. Omega square value minus 1. 1 minus 1. Here it is 1 is there, omega square minus 1. 1 minus 1, 0. 0 into something, 0. Because n is even. N I took even, hence result will be 0. If I took n odd, like 5th root of unity or 7th root of unity, so your result would be 1. Just remember like a standard result. Okay students, what are omega, omega square, omega cube and so on? Omega power n minus 1? Complex roots of, okay, so, we should not call as complex roots, just roots of nth root of unity. Because here for n is 4, you are getting real root na, say it as roots of nth root of unity. Simply call it as nth root of unity. Okay students, in this principle, when n is even, result would be 0. If n is odd, result would be 1. And one more important, okay, relation here you would have to remember. So 1 power p plus omega power p plus omega power omega square whole power p omega cube whole power p and so on omega power n minus 1 whole power p. So this result would be 0 if p is not multiple of n. P is not multiple of n. This result is n if p is multiple of n. Okay, here what you people are doing, you are raising the powers of this roots up to p. Just here we have taken 1 power p, w power, omega power p, omega square whole power p, omega cube whole power p and so on, omega power n minus 1 whole power p. Where p is a natural number, n is also natural number. So this result is equal to 0 if p is not multiple of p. Not multiple of n. N means what? Nth root of unity, n. Here it may be any natural number. Here p they may give you any natural number. But whenever the p is not multiple of integral multiple, say it as integral multiple. If p is not integral multiple of n, result would be 0. If it is multiple of n, result would be n. Okay, if you want to take any values for n and p, you can check. Suppose if you take n value is 4, p you can take any multiple of 4 like 8 to 2 value 16. In such case, result would be 0. If p is not multiple of 8, result would be n you will get. Okay students. So these are some important conceptual points of this nth root of unity. So this class here itself I am closing. Thank you one and all.